Right, final video, year 11s. This is now the last part of antiderivative or integration. So in our lesson, I mentioned about indefinite integrals, which in the last two videos was all about. And then I also mentioned the second skill that you needed to know was definite integrals. Okay. So remember, the whole point is definite integrals is going to allow you to find the area under the curve. Okay, so area under the curve. So let's take an example. Let's say I had the graph x squared. X squared is always nice because most kids understand it. So let's say the curve is equal to x squared, right? Now, you can't find the area under a curve unless I tell you an interval. Because you see, if I said, remember we talked about indefinite integrals, let's say I wanted to find the integration, which is apparently the sum of all rectangles, and it's x squared multiplied 2. So length times width. This is meant to tell me the area under x squared, true? And the area under this curve would be, you know, all of this region here. But you see, if we actually did the antiderivative right now, what you guys learnt from 17e is you would have said this is x to the power of 2 plus 1, which is 3, over 2 plus 1, which is 3, plus c, don't forget that. You see, this is apparently the area. But what is the area? See, I don't know. It doesn't really tell me anything. It doesn't tell me a value. And the reason why is because I haven't told you the interval. I haven't told you where, from where. Okay, so let's say I do tell you from where. Let's say I tell you that I do want you to find the area of the curve, okay, but from 1 to 2. So let's say this is the area portion I want. Obviously I can change that, but let's say I want it from 1 to 2. Then the antiderivative from 1 to 2, so smallest is always on the bottom, highest value on the top, of x squared dot dx should give me the area. Okay, now we just found out the antiderivative of x squared, and remember in classes what I showed you, I said the antiderivative, which we wrote as x cubed on 3, I told you that you didn't have to put plus c because they eventually cancel out, but I'll show you again just in case you forgot. I'll put the plus c in, okay, because that's what we got over here, right? We said it's from 1 to 2. Now, if you've forgotten, in class I have shown that this is a summary, that the antiderivative of f of x dx between a and b, a being the smaller number, b being the higher number, I gave you guys this rule and I told you to copy it down. This is your second time to copy it down. Okay, so it is capital F of b minus capital F of a. Now that wasn't by accident. Capital F is saying that it's the original function. Little f is the derivative of the original function. Okay, so this is the rule. Now, this is where all the proof comes in, like how antiderivative actually equals to the integration. The whole theory is called fundamental theorem of calculus. Okay, now, those who want to look at the proof and understand how we know that the antiderivative actually equals to the integration, then you can type it up in YouTube and go to Khan Academy and he'll show you from A to Z how it's true. It is not part of our course to know that. You just needed to know that it is the area under the curve. You don't need to know the proof, and you're not getting assessed on it. So I'm recommending that you don't do it because it might confuse you unless you're pretty good at your maths and you're pretty happy to challenge yourself, then by all means do so. Okay, but anyways, we're going to go with this idea. This is where it's important. This is called the fundamental theorem of calculus right there. Okay, that's what they discovered, that if you took f of b minus f of a, that should tell you the integration between 1 to 2. This is what it should tell you. Okay, so this is what we wrote. We said the antiderivative of x squared gives me this. So this is my capital F. Right there, right here, just don't forget, this is now your capital F. Because this was your small f, f of x. So you found the antiderivative. Now, according to the rule, it says you're going to sub in f of b. B is the top number, so the top number is 2. So you're going to sub in f of b, so f of b means you're going to sub in 2, so I'm going to sub in 2 now, so it's 2 cubed over 3 plus c. Okay, minus, now they said sub in a. A is our 1, so I'm going to sub 1 into the equation. So here we go, so we've got the minus, here's the minus sign. That's in the second bracket now, so it's 1 cubed on 3 plus c. Okay, see what I did there? So I'm just using the rule. This is the fundamental theorem of calculus. And we can see that 2 cubed is 8 on 3 plus c. So this is the first bracket. Minus, this is 1/3 plus c. Now, the reason why I put the brackets in, I'm emphasizing it, is because I want to remind you that when you put a minus on the outside, it's minus of the 1/3, but it's also minus of the c. So what you end up with 8 on 3 plus c minus 1/3 and minus c. That's why the c's always going to cancel out. So that means next time when you do your antiderivatives, but for the definite integrals, you don't need this plus c. You know it's going to cancel out. But you can put it in by all means. You'll find that it always cancels out. Okay? But anyway, so you end up with 8 on 3 minus 1/3, and that gives you now 7 on 3. And what that tells me is you get 7 on 3 squared units, which means the area under this curve here is 7 on 3 squared units. Okay? The reason why we say squared units is because I don't know if it's in centimeters, meters. Obviously, if it was in centimeters, then you say squared centimeters. Okay? But because we don't, we say squared units. All right? But this is called definite integral. And there is no, I'm pretty sure there's no exercise on that. It's just a worksheet. I think I gave you a worksheet on it. If not, tomorrow's lesson and Wednesday, you will get one anyway. But that should summarize the definite integral. So there's only one extra step. So you now know how to find the indefinite. Okay, and then all you have to do was sub a and b and subtract from each other and simplify down to get. See, this is the actual area. That's the units. What was this up here? That was your area function. So not until you're given an interval. Once you're given an interval, that's when you can find the area. If they don't give you an interval, well, how are you supposed to know what the area under the curve is? It will be infinite. Okay? It's very similar to the gradient or the derivatives or differentiation. Normally when you derive, it tells you the gradient function, but not until they tell you where the point is, that's when you know the gradient of the tangent line. So just to illustrate what I was saying, see, when you find the derivative, you only find possible tangent gradients, but not until I tell you I want it at this particular point at x equals to, I don't know, let's say 1. That's when you can find the gradient at this one point. Okay, so without me telling you the point, then you don't have an answer. That's why if I gave you y equals x squared and I say find the derivative, most of you would have just said 2x, but 2x is not a gradient. See, I don't know where, so x equals what? I don't know which point. So very similar to that, the area function is when you find the antiderivative, okay, but until you're given an interval from a to b, then you get the area. Similarly here, you're given a function, you find the derivative, then it gives you the gradient function. But until they tell you a point, that's when you can find the gradient value. Okay, that should summarize what we've learnt last lesson. So you got your indefinite and definite integrals. I'm trying to remember because for a while my computer wasn't updated, and so a lot of videos haven't been recorded. Two of which was important. We had stationary points. Okay, I know you're missing maximum and minimum questions. We've done that twice so far, so hopefully if you missed out on one lesson, at least you were there for the maximum minimum questions. It was just the idea that you get your sometimes you can get a graph where it looks like this, and the local max, local minimum happens to be the absolute minimum, absolute max, or you could get a question where it looks like that. Okay, so if you get that, then it just so happens that the stationary points, which is the maximum and the minimum, is not the maximum and minimum values. This point is the absolute max, and this point is the absolute minimum. Okay, and that's what we've done in the past, but we didn't get to record it. But we will do all that in our double session tomorrow. Okay, we should be able to summarize it all. SACs on Friday, and I'm really just testing all these basic skills. Can you derive all kinds of functions? Can you find the gradient? Can you find the tangent? Can you find the normal? Can you find stationary points, maximum, minimum? And I will leave... Maybe I'll leave antiderivatives out of it and we'll just practice it for the exam. Okay? Maybe. I'll see how we go tomorrow. I don't want to overload you guys, but you know, the exam's just around the corner, so just got to make sure you're all ready. But that's it. Thank you. I'm going to pause the video.